Hey guys, welcome. I have some more things I've been looking into about Arizona. Yesterday or last video, probably yesterday, maybe this morning, talked about this video and how we mentioned the Appalachians were found, grains of sand were found over here from the Appalachians in this region. But I just wanted to play real quick the segment. So he says,
And so if you start eroding the Appalachians, you get a bunch of these zircons out. So the thing that's interesting, one, is that we're out here in western Arizona, and in the early Triassic, the sediment was largely dominated by grains that originated from the Appalachians. But then over it has about the same signature. It's got this 1.7. It's got a big Grenville kick, and then there's a whole bunch of 5 and 600s. Those are we don't have any of those rocks in the western U.S. So all those things had to come from the Appalachians, be transported across the whole continent by big river systems, and then brought into here. And so what this data shows
pardon me, I muted myself, but all.
is that the intuition we had that there's gypsum here and there's gypsum here, that the buckskin was likely to be Moenkopi, is borne out by the detrital zircons. They have the same detrital zircon
Okay, so. That's.
signature. And so at this point, we are, we don't, I don't think you prove anything in science, frankly, ever, but you can make yourself, 99.9993%
I,
same signature. It's got this 1.7, it's got a big Grenville kick, and then there's a whole bunch of 5 and 600s. We don't have any of those rocks in the western U.S., so all those things had to come from the Appalachians, be transported across the whole continent by big river systems, and then, brought into here.
transported across the whole continent by big river systems and brought in here. So many contours. Okay. Like this. So we got this system coming this way that goes down here, and then across this way, and then a system over here. But this one's going by the Appalachians. So then it goes over this way, goes down here, and then over this way, and then seemingly goes through and up over here, and does in fact deposit that. And then I mentioned that this region and maybe this region had Appalachians, particularly along them, and I did end up finding. I guess this is not the right tab. This place, Anadarko Basin in Oklahoma. So like, here it looks like. Here's the circle. So here, I believe. Almost like it came in and then went up that way against the cross current. Like there's a current coming in this way that this runs into, and then it deposits up here Appalachian materials rather than like specifically here. I don't know what to make of it. Okay, so there's that. Let's go back here, though. Okay, so I spent today largely checking out some details in as many Arizona-based lectures I could find on YouTube. So, as like as an entry point to this region over here, which is led me into Colorado Plateau a lot. This region I've been calling the Ammonite structure here, which I even more firmly hold now, because of reasons that seem pretty interesting. So let's just go through some details. This is called the Colorado Plateau. The region of the Ammonite is the Colorado Plateau. And then the Mojave Desert basically starts over here. And then I believe it goes like generally like in this region, maybe down here. And then up to about here, I believe. Something like this. And then the Great Basin is in this region up to here, pretty much. Maybe up to there, too. So there's the Great Basin, there's the Mojave Desert, and then there's the Colorado Plateau. And then between them, right here, is the Triple Junction, I believe, generally here, where the three of them intersect and interact. So there's parts of each within, and they're intermixed in ways. So it's called the Triple Junction there, where layers west of a fault line that is, I believe, somewhere, maybe here, maybe that. Maybe that. Wherever this fault line is, it might be there. It's called the Hurricane Fault. Let's see what's on here. Just that. Boundary between and basin running from Cedar City into northwestern Arizona. So Cedar City. Here. So it's running this way. This thing here. I guess, in this region, I guess. Maybe there, I don't know, this way. Down to here, maybe. Maybe even... So everything west of this, over here, is considered part of the Triple Junction, where the layers are twisted and contorted by what's considered seismic activity. Colorado Plateau made up of orderly layers. So to the east of this fault line is the Colorado Plateau, which is distinctly different. So if we look at Colorado Plateau images, it's kind of like that, just layers. Whereas this, even though it says Colorado Plateau, is probably not actually within it. Let's see where the wave is. The wave. Oh, just within this thing. The wave is like right along the very outer edge of this current flow. It wraps around here as like a maximum edge. In general, though, this is considered flat and layered, just like simple. Where over here, this region, and down here, like right here, the transition zone, maybe especially the right here, or this region is twisted and contorted. Okay. Let's go through some more stuff real quick. I don't want to forget what I want to say, but about that right there, but let's go through some more stuff. Colorado Plateau made up of orderly layers. Okay. Considered to have formed the Colorado Plateau. Considered to have formed from sedimentary deposits in a wet environment over hundreds of millions of years. So, yes, water was involved. That's good. But interestingly, it was shallow water and not always. And it seems like this structure may have occurred later in the process. Like initially, it was more so just depositing layers, but as the water got more like pressurized and higher flow rates, then it really ended up focusing this structure into being here specifically, where it didn't happen like all over the globe. It happened here relative to here, creating these currents across from one another that don't really have the same. Maybe, I mean, I guess I haven't noticed elsewhere, but I doubt there's anything of the same nature, of the same scale. Maybe of the same nature, but of the same scale. So shallow sea. So it definitely, like, according to modern interpretation, it was formed in a shallow sea that then had sand dunes involved as well. That became sand dunes, I guess. I'm not sure exactly how it solidified without just concreting pretty much out of a paste water-based material that like dried. I'm not sure why it wouldn't just have been considered that way, and maybe because it dried after it deposited. There's like this step of depositing where it's wet, and then there's this step of drying where it dries. And so we say, like, at first it was in a wet climate, and then it was in a dry climate. maybe. Some extended layers over longer time, some thinner layers. So there's different thicknesses of layers, which makes me just think of kind of like a separator layer between like a anode cathode material. Like if we're making a battery, the objective is to have the least non-energy storing material as possible. Like we don't want a huge separator and then like a very thin layer of anode and cathode material. Like we want the thinnest possible layer that prevents crossover of like the actual material, but allows for exchange so that there can be like a actual energy. So that's my thoughts when it has that like thick layer and then a thin layer and then a thick layer. Like it really makes me think of it's doing something of that nature where it's like separating some base material into a more positive and negative with separator between kind of structuring that almost is like a huge battery itself. Whoa. Most most places on Earth with similar layers have been twisted and deformed, but not the Colorado Plateau. So again, the way it's layered, although I'm not sure if that's just me paraphrasing something that they said. I mean, I just kind of took their word for it and interpreted their word, so maybe that's not quite what they said. I feel like there's probably other places that are similar in the more flatness to it, but maybe for specific reasons, I'm not sure why. It's very unique. It's certainly coming across as a very unique place on Earth, the Colorado Plateau in general. Great Basin, Mojave Desert. So again, Great Basin over here, Mojave Desert. 70 million years, portions of the Colorado Plateau began uplifting. So right around the KT boundary, this starts to uplift. And then 20 million years, the uplift accelerated, which is a little odd, but it also makes me think of Yellowstone. And so, like, it's almost like there's a container here that kind of solidifies, and then a current that was passing through actually ends up going more into the container, but then it, like, uplifts later on. 20 million years when the process was kind of slowing down. Maybe it even was flowing this way and then flowed back that way as it like went, almost like the energy went to a peak and now it's just falling, but it does so by the current flowing in the other way that then cycles all the way around, like almost like the subtlest energy level drops until it like drains. And then it comes back up and does the same kind of processes. Something of that nature. Maybe not repetitively, purely, but adjoining provinces uplifted the entire province. So the entire province of the Colorado Plateau is uplifted relative to its surroundings. Imagine this is the Colorado Plateau and I put some pressure on it and you get the point. This thing stabbed me trying to grab it like that. Okay. So this whole region uplifts by itself, though. It's almost like it's separate and distinct, like an ammonite, where it's like its own system, just kind of sitting there. This huge ammonite, just like, for instance, in Hawaii, we see the subtle one here. That has another bigger one here, the center here, that spirals out around here and comes over this way. I know it's kind of ridiculous if you don't believe me in a lot of things, or maybe you don't see that as the most compelling evidence. Here's a shallogrammy looking thing with this really strange shape here. Little things there. But, yeah, so maybe that. And then, again, let's look at Skull. Let's look at Skull Rock. Skull Rock. Like, maybe this image. Here's Skull Rock, right? Here's an ammonite. Let's find the best like clear pictures of it. Like that one there is pretty incredible looking. It's going up, over, up, over, up, over, up, over. It's kind of reminding me of the way where is it? Here we go. The way this ammonite broke. I posted pictures of this. Here's just the ammonite, but you can see it broke with like a mini ammonite missing, but then it broke at certain angles that have steps to them that I basically mapped, or I took the picture and I put a protractor atop it like so, and found a 90-degree angle, which I think is relevant. Like maybe I'm forcing it to a degree. Certainly around 90 degrees from this breakpoint to this breakpoint, and then another question mark to this point, and another question mark to this point, which is then 105, 104.2. So my thoughts are every 15 degrees from 90 up are the ones that tend to be visible, I guess. So like there was 90, now we're seeing 105 almost 120. Like it doesn't have to be. So that step-by-step thing, maybe that's going on here in its own like fractal way. But let's find that picture. This one, this is just incredible. Also these things. But it's very rounded. We can see how rounded this is. And then it has this little place where it goes into the nucleus pretty much, and then just the features, all the features, and then it goes down this way, and it also forms in this little nook. Made me think of the ants. Like, we're like little ants. I'm like, what if Earth is like this? Much more like this than we realize. Like, this is a whole thing where, like, this is like this ammonite. I know. But interestingly, so coming out of this ammonite over this way, at Hurricane, there's the Hurricane fault line here, going down here. Everything west of it. I already talked about that, didn't I? Damn, I already talked about it. Pardon me. I already talked about it. Okay. Let's just keep going. Mojave debated if southern extension of Great Basin. So there's some debate in the geological community if the Great Basin and the Mojave Desert are really more just one thing in some regard, but it's clearly like has differentiated features, but like it's considered, maybe it's the same, is because like it probably is essentially like related to the same current flow coming this way, I guess, as well as over from here this way into here. and whatever else may be contributing, it all then leads to like one overall affected region, but with different like kind of like stem cells becoming like the head and the neck and the body. San Andreas Fault is the western boundary. I found this really interesting, right? I think here. The Mojave Rift Zone. Let's check this out. Mojave Rift Zone. Maybe just images then. They drew it as generally parallel, maybe is to the San Andreas Fault. San Andreas Fault comes this way and then divides. I think it divides over here though, like in, maybe not divides, but it has its adjacent currents flowing with it that are influencing the terrain also. Let me just real quick see. Most of the Colorado Plateau fades out, entering Mojave, well-drained plains, high desert, alkaline-rich soils. I just noted that. Great Basin. Okay, Okay. Great Basin, so the three regions. This region up here, the crust is stretched, so that's something of note. Is it like got flattened, maybe spread out amongst the area as much as possible, stretched, and then became ripply by just the water that was atop it, I guess. This is real interesting. The water does not drain out of the Great Basin into the ocean. It just drains into lakes, like the Great Salt Lake, where the water drained into it rather than leaving the region, and other places like probably here, definitely here. And just apparently several of them, probably maybe that one, I don't know if that's lava flow. Oh, that's not even water. I thought that was water. Whoa. Okay, so water does not drains to the lakes, basin, and range trend. So these trend north-south, generally speaking, although it looks like they're not really trending together. And if we look a little closer, they almost like point to a focal point. Like maybe up here even. Point is, they're not exactly north-south. It doesn't matter, but some areas drain to basins around them and go no further. Okay. Triple junction runoff mostly to Virgin Ocean, or Virgin River to then to the ocean. So that's a key difference between the Great Basin region and the Triple Junction is that the Triple Junction water drains out of the region and to the ocean, wherever here it does not. And then the Triple Junction was described as like a blender was turned on of all three. So like literally a blender blending the three constituents was turned on is kind of how it's viewed. And apparently it has the largest laccolith possibly in the entire world, where a laccolith is an unerupted volcanic intrusion below the surface, pretty much. That pushed up the surface like a dome without actually venting is a laccolith. Let's see, largest laccolith in the world. Pine Valley Mountains. Let's see where that is. So right here at the Triple Junction, the largest laccolith in the world, without even like intending to find it by looking for like Utah or something, just Googling generally that. So that's a pretty good sign that it is at least in the top. Maybe maybe it's the most talked about as the largest laccolith. It is the largest in the United States and perhaps in the world. So at least like saying we don't know completely. And there may be others. Maybe. So it's a huge laccolith. Okay. That's something of note. So it's like a blender of all three. It's a huge laccolith. Lava rose as cinder cones around hurricane faults. Okay. So, this is where I finally get to something pretty exciting. YouTube. Your clips. Same clip I play all the time. About lava flows. Lava flow causing a rotation this way on the surface. And then this one's going counterclockwise, and this one's going clockwise. So there's two of them, one on the back of the other. Possibly even related like that. I don't know if that's really related where like this points at that. I don't know. This does kind of point in its direction, generally speaking. Although I think that, I don't know. Anyway, but there's the spiral here. And if we look over here, do you see what I see? Notice these again. North-south, not quite north-south, but they're going north-south-ish. But if we zoom in here, they start to like go out of phase here. This especially. It's a little odd. It's like boom. Maybe it's counter to this one. But if we hypothesize that this right here is kind of the edge, in a similar way to this over here is the edge of an ammonite. So like there's an ammonite that's hypothesized that's here, that starts maybe here. Oh my god, look at that. Holy shit. And then it wraps around. We can see the inner portion here more. Goes across this way. Maybe back this way. And maybe somewhere coming back in. Possibly all the way out here. Honestly. Like right along the boundary of the Grand Canyon at its furthest. Where this current's coming through here. So it's like coming up this way, turning around, going this way, and then a cross current's coming in here. And so this material's coming in. This material's coming in. And I guess like this is going up this way and then coming back around. Maybe. Maybe it goes up here and like fills this and comes back through a specific way. Or just in general. I mean, it's just so close to it that it's bringing material from this in general to be part of this region. And then it's swirling this region right here, the triple junction. Literally swirling it in an ammonite shape and mixing it, and to a point where then it's actually creates a structure like this on the back of the ammonite. Wonder if this goes over this way, goes up here and in. But so notice we just found the largest laccolith in the world is centered on this ammonite. And if we picture, I don't know what you guys know about ammonites. Flat ammonites. Some ammonites, in my experience as a YouTube viewer of people who search for ammonites, some of them can be very, very thin to a point where they're considered flattened. Almost like they have yet to be inflated and they're just like forming a base, like connected matrix structure of the shell that then still needs inflated more. And like in this case, it literally was inflated. And in this case, or maybe in this case, was just uplifted, like, and not inflated directly. It was more an undercurrent below the ammonite, whereas in the laccolith of this ammonite center is more the actual ammonite that inflated where the current flow was. Over here is below, but over here it was actually within the tier of the layer, so that it inflated it to make it even more ammonite-like. Maybe. So the triple junction, I mean, this shape right here is so ammonite-like. It's even got like a 90-degree right there. Maybe not 90. Reminiscent of this. Coming down here, maybe going around this way, and then over. Oh my god. And then this shape here, where how it comes to basically like a hexagonal little thing at the center. Very much makes me think of a current that's like wrapping in and getting kind of stuck here at the center and building a wall and just structures around it that then spreads out to the overall region that it influences here. Another thing is the ancestral Rockies formed and then the sediments were washed away. I believe maybe even in here. Oh my god, could it be that the ancestral Rockies fed into the triple junction? So like it gave birth to another ammonite. The ammonite gave birth to another ammonite and contributed the ancestral Rockies in so doing. That would be so crazy. Remnant. I don't feel like reading it. Three red dots correspond to my discussion of erosional remnants at the end of this post. Paradox Basin. Oh, what is Paradox? I should have looked into that one as soon as I saw its name. Unlike most of the Rockies, Paradox Basin is an asymmetric foreland basin, structural basin that develops adjacent and parallel to a mountain belt. Located mostly in southeast Utah and southwest Colorado, but extending into northeast Arizona and northwest New Mexico. Oh, so this is huge. Is that it? Maximum extent of salt in paradox formation. So there's paradoxically salt here. May have been trapped there for several 100 million years. However, in 2022, researchers attempting to date the basin unexpectedly discovered relatively young water as far down as 3 kilometers. The fresh influx would have been delivered by rainfall, snowmelt, or natural aquifers as recent as between 400 and 1.1 million years ago, making it Paradox Basin. Because the Earth expanded. Desire to preform strange and unexpected things. Dolores River. I don't know if it continues. But so, if we look over here, let's look at this. At this little point here, and just say maybe there's a flow going this way at a general maximum width over here that then comes across here at a maximum width. Then it points right to the boundary of this. This goes right up to there, where then this ammonite shape is. And then probably, honestly, this one, this interior one that's like dark here, that goes up to this edge, this way, continues through to the far edge of this spiral that comes around here and goes around here. So the far edge, or inner edge, far edge, boundaries of that, like there's definitely no happenstance there. Coupled with, okay, maybe we're getting somewhere. Where this current comes in this way, divides, goes some this way. Some this way, some this way. Comes across here. Comes across here, like there. Something like that. Possibly as different boundaries. Like initially it went here. And then it moved over, like it filled the pressure here and just ended up building layers this way until it reached over here maybe. And then it like switched to this side to fill more this way by like bending the wrist off of here, so it ended up going more this way and going that way maybe. Separating, actually, probably hitting this thing, separating this way, as well as starting to send a current, more and more focused beam this way that runs into resistance and just goes up this way, like in the same way. But outside of the resistance then, which then it goes into the Pacific that was beginning to form. I definitely, the moment I saw this, I was like, that's legit right there. This thing here that goes up to this little, like, rattlesnake tail. There's definitely something to that. That's a huge, like, circle. Half circle, semicircle. Okay, let's see if I can find. Oops. Ancestral triple junction. Ancestral Rockies. Maybe that would be a good search. SOA triple junction. That could be talking about an ocean triple junction. Holy crap. Oil, gas. I mean, that's probably ocean. These arcs right here make me think something was coming up this way. Hit this, maybe kind of went over there. Maybe not, maybe coming around here. Wrapping up this way. That didn't go out that way. It's even got the way ammonites have the like smooth section. Like this. That's probably not the representative though. It's kind of opposite. Holy crap. It's not gonna have anything that I'm looking for. This kind of represents it where it just has different materials. Again, a difference to it. Difference to it. So like a difference to it here. Maybe even it goes into here. I was thinking it ends kind of here, and this actually goes up. and is like overlaid. Overlaid by something that's reaching down to the terminal too, pretty much. Coming all the way from Yellowstone. Reaching down, taps the terminal. Okay. Is that everything? It's probably good. Alright, till next time. Thanks for hanging out, y'all. Peace out.